Today's lesson is how to solve for an angle or a side using law of sines. So let's first discuss what law of sines looks like. Now, law of sines is a proportion, and the way that we want to set this up, and I'll kind of go over to this side. What you're going to do is it's the sine of the angle, so sine of theta, over the opposite side. And that equals sine of, and I'll call this beta, sine of beta over its opposite side. Basically, all you're doing is, I've written on other papers. Oops. All you're doing is creating a proportion. So what you need are two angles and two sides. So let's go ahead and head on over to our first problem. In our first problem, what we're going to do is solve for x, and x isn't actually a side, and this is a great way to know we're using law of sines, two angles, two sides. So what we're going to do is start to label. I'm going to label 44 capital A, and across that is little a. So again, the capital letters are just angles, lowercase letters are sides. Then I'm going to label, I've got capital B, little b. As I can tell, I have doubles, so just like what we did with trig SOHCAHTOA, we're using the double rule again. So I've got A and 7, B and X. Doubles and doubles, that means I'm going to use angle B and angle A. So let's set up our first problem. This is going to read as sine of 44 over its opposite side, 7. And then we do the same thing on the other side. Sine of 53 over its opposite side of x. So all that's happening here is I'm just creating a proportion. Sine of the angle over its opposite side equals sine of the angle over its opposite side. Now this is a proportion, so all we're going to do is cross multiply. So numerator of the top times denominator of this bottom, or of the second. So sine of 44 times x. It's just going to be x times sine of 44.
Austin Harold, please come to the main office. Austin Harold, please come to the main office.
Okay, next, denominator of the first times numerator of the second. So 7 times sine of 53. Now, sine of 44 and sine of 53, those are big, long decimals. So we want to contain those decimals until the last step. So my variable I've located as x. In order to get x alone, this is the same thing as SOHCAHTOA. So x is being multiplied by a number. To isolate x, I move the number to the other side through division. So sine of 44 cancels, and I'm left with x equals 7 times sine of 53 over sine of 44. Now my x value is isolated, so what that means is I can pick up my calculator, and this is still trig, so I still want to go ahead and check the mode. So by pressing the mode button, I pull up all of this info. Degree is highlighted, which is a good thing, so I'm going to press clear and move on. I'm going to type it in how I see it, 7 times sine of 53, closing your parenthesis, that is very important when you're dividing, by sine of 44. If I round to the nearest tenth, this 4 is not high enough to bump the 0 up to 1, so my answer is just 8.0 or 8. Okay, let's try another one. So on the second one, again, law of sines, I only have information about two sides, so that is your hint. I'm going to go ahead and label this capital A, this little a. So notice how x has a, so we are going to be using angle A. Then I'm going to put a capital B at 51 and a lowercase b over here. And then we're going to just utilize C. Capital C, little c. Using the rules of doubles, I have A with X, C with 27, but nothing with B. However, I need to use angle C. So what I'm going to do is add these up and subtract from 180. This is a triangle. All triangles add to equal 180 degrees. So 51 plus 39 is 90. 180 minus 90 is 90. So that means this angle C, is 90 degrees. To determine what angles I'm going to use, I want to use my doubles. So C has 27, so I need to use C. A has X, so I need to use A. That means B is out because there's nothing with it. We just had to use angle B to help us get C. So now let's set up our ratio. So I have sine of 39 over X equals sine of 90 over 27. So it's sine of the angle over its opposite side equals sine of the angle over opposite side. So that is for A. And this next setup is for C. What I'm going to do, cross multiply. So sine of 39 times 27 is just 27 sine of 39. X times sine of 90 is just X times sine of 90. I'm going to identify my variable that is crucial when solving these. I need to know what I'm solving for and what I need to isolate. So I'm trying to solve for X. X is being multiplied by sine of 90, so that means I'm just going to undo the multiplication through division. Signs cancel, and I get X equals 27 times sine of 39 over sine of 90. X is now isolated, so I'm going to go ahead, pick up my calculator, and type it in how I see it. 27 times sine of 39, closing those parentheses, divided by sine of 90, closing parentheses. Rounding to the nearest tenth, this 9 bumps this 9 up to a 10, which bumps the 6 up to a 7. So our answer is 17. Let's practice using law of sines to help us know we're solving for an angle. So again, 2 angles, and in this problem I gave you 3 sides. It is really crucial to label. So by this letter, I'm going to put a capital A. Opposite of it is little a. Then I'm going to use capital B at 129, lowercase b at 25. And notice how I already have my doubles here. I've got 11 with A, 25 with B, so we're not going to use this one because my variable is here. So let's set up our problem. Sine of X over 11 equals sine of 129 over 25. And again, all we've done is set up our proportion. We need 2 sides and 1 angle to do this problem correctly. So there's a little bit of extra info on this example, just to make sure you're paying attention and solving the right way. So I'm going to cross multiply. Sine of X times 25 is just 25 times sine of X. 11 times sine of 129 is 11 times sine of 129. This one is very tricky because my variable is now an angle. When the variable is an angle, you need to do an additional step. The 25 is being multiplied to the trig function, so I'm going to divide the 25 away. The 25's cancel, and I'm left with sine of X equals 11 times sine of 129 over 25. Again, my variable is still the angle, so in order to solve this problem, I need to use the inverse trig functions. Remember, we talked about those in our last video when we practiced solving for an angle. This is sine, so I'm going to multiply both sides by sine to the negative 1. What that ends up doing is canceling our trig functions, leaving us with X equals sine to the negative 1 of 11 times sine of 129 all over 25. My X value is not isolated, so I'm going to type it into my calculator, and it's very, very important that we type this in correctly. So I'm going to press second sign to pull up the negative 1, and I'm going to make sure to put everything in parentheses. I got 11 times sine of 129, closing parentheses, divided by 25, and we're going to close those open parentheses that we started with. Since we're finding an angle, we're going to go ahead and round to the nearest whole number. So this 9 bumps up to a 10, bumping 19 up to 20. Okay, let's do the very last one. I think I'm running out of paper, but that's okay. Let's go ahead and label. I'm going to start labeling again at the angles. Capital A, I'm going to put with the 97. That means lowercase a goes with the 22. Capital B is going to go with X. Lowercase b goes with the 19. And notice rules of doubles. I've got A with 22 and B with 19, which means that 9 is out. Okay, let's see here. I've got a little crowded over here. All right, let's try this out. So I'm going to go ahead and set up my problem just like before. Sine of 97 over 22 equals sine of X over 19. So this first one is the A ratio, and this second one is the B ratio. Again, A, B, and C, those are just arbitrary values. We are just using those letters because they're the first 3 letters of the alphabet. The letters only hold meaning to help you know capital goes with the angle, lowercase goes with the side. So now we're going to cross multiply. Sine 97 times 19 is 19 sine of 97. And then I have 22 sine of X. Again, before I start, I need to identify my variable as X. So to isolate X, I must move the 22 through division. So I'm left with sine of X equals 19 sine of 97 over 22. My variable is still not isolated, so what I need to make sure I do is use my inverse trig function. So I'm going to multiply both sides by sine of -1. And what that ends up doing is canceling our trig functions. So this -1 and sine go away. Let's see, I'm going to go ahead and write it over here, make it a little bit neater. I'm left with X equals sine to the -1, and then I'm going to write my parenthesis stuff in here. So 19 times sine of 97 over 22. And now my X value is isolated. Picking up that calculator, I'm going to type it in how I see it. Second sign brings up the -1. 19 times sine of 97, close parenthesis, divided by 22, and close the parenthesis. Rounding to the nearest whole number, that 0 doesn't move, so this ends up just being 59 degrees.